Let's be honest, haven't you ever wished you could predict the future? Not just make a good guess, but actually truly know what's coming? Well, way back in the 19th century, one of the sharpest scientific minds out there proposed that this wasn't just some fantasy, but a theoretical certainty. He pictured a universe so predictable, its entire future was already written. So today, let's dive into this powerful idea and the three massive scientific revolutions that completely tore it apart. So, meet the man behind the idea, Pierre-Simon Laplace, an absolute titan of French science. Back in 1814, he came up with this thought experiment about a vast intelligence. Imagine some being that could know the exact position and the exact momentum of every single particle in the universe. If it had that perfect snapshot of the present, and it knew all the laws of physics, then boom, it could calculate the entire future with perfect accuracy. This idea got a name, Laplace's demon. And it's basically the ultimate mascot for an idea called scientific determinism. This is the vision of a clockwork universe. This grand, intricate machine where everything, from a star exploding millions of light years away to the thought you're having right now, is just the next inevitable tick of a cosmic clock that was wound up at the very beginning of time. I mean, it's a powerful idea, right? Maybe even a little unsettling. But could it actually be true? Well, as it turns out, science itself would spend the next 100 years or so discovering that the universe is just way weirder and far less predictable than Laplace ever could have imagined. That perfect clockwork universe was about to have some serious wrenches thrown into its gears. So, the first major blow to Laplace's grand idea came from a place nobody in the 19th century could have possibly seen coming: the totally bizarre and fuzzy world of quantum mechanics. See, the demon's entire job depends on knowing the precise position and momentum of everything. But then along comes Werner Heisenberg's uncertainty principle, which reveals this fundamental roadblock that's just baked into the laws of nature. And this isn't about us not having good enough tools, it's a basic rule of the universe. The more you try to pin down exactly where a particle is, the fuzzier its momentum becomes. You just can't know both perfectly at the same time. And that is a huge shift in thinking. In the classical physics that Laplace knew, you can perfectly predict the arc of a thrown baseball. But down in the quantum world, certainty just goes out the window, and probability takes over. You can't ever know for sure where an electron will be. You can only know where it's likely to be. So at its very core, the universe seems to run on odds, not on absolute guarantees. This was so revolutionary that even the great Albert Einstein had a hard time with it, famously saying, "God does not play dice." But sorry, Albert, decades of experiments have shown that, nature does seem to play dice at the quantum level. And that creates this impassable wall for our demon. It can't even get the perfect starting data it needs to even begin its calculations. Okay, but let's just pretend for a second we can ignore the whole quantum world. Even if we lived in a purely classical, predictable universe, a second, equally massive problem pops up when we start looking at really complex systems, like the weather. And this is where chaos theory crashes the party. What it tells us is that even systems with zero randomness, systems that are technically deterministic, can still become completely and utterly unpredictable. And why? Because they have this extreme, almost paranoid sensitivity to their starting conditions. It's the reason why, even with all our supercomputers, weather forecasting is still so tricky. To really get what this means, let's go back to the 1960s and meet a mathematician named Edward Lorenz. He was running these early computer models of weather patterns, and for one of his simulations, he started with this number as one of his initial values. So, a little while later, he wanted to take another look at that same simulation. He went to re-enter the number, but, to save a little time, he just rounded it off. He typed in just the first 3 decimal places. Now, that is a tiny change, right? Less than 1/10 of 1%. It shouldn't really matter. Or so he thought. He was completely wrong. When Lorenz came back to check on his work, he found something absolutely shocking. That tiny, insignificant little rounding error had been magnified over and over and over again, leading to a wildly different long-term forecast. One run predicted nice, calm, sunny skies. The other, it predicted a massive storm system. And this became the textbook example of what we now call the butterfly effect. And for Laplace's demon, this is devastating. To predict the future, the demon wouldn't just need precise measurements. It would need measurements with infinite precision for every single particle in the cosmos. That's just physically impossible. The tiniest unmeasured atom could throw off its entire prediction. Okay, so quantum uncertainty says the demon can't know the present perfectly. Chaos theory says it can't measure the present precisely enough. But this third and final challenge, well, it's the most profound of all. It attacks the very idea that the future can be calculated in the first place. So let's just grant the demon its impossible wish. Let's pretend it has perfect, complete, infinitely precise knowledge of the entire universe. It somehow gets around both quantum physics and chaos theory. Even with all that godlike power, it would still fail.
The core of this final problem is a concept called uncomputability. And I think physicist Toby Cubitt just sums it up perfectly here. Even if you have a god's eye view of a system, you might still have no idea what it's going to do next.
Think of it this way. For some really complex systems, there is no formula, no algorithm, no shortcut that can predict their future any faster than the system just living it out. The universe itself is the only computer powerful enough to simulate its own future. The future isn't just hidden from us. In a very real sense, it's genuinely unwritten until the moment it actually happens. So, after this three-pronged attack from science that lasted more than a century, that beautiful, elegant vision of a perfectly predictable, clockwork universe was completely dismantled, piece by piece. So let's just recap those three killer blows. First, quantum uncertainty proved that you can never get a perfect snapshot of the present. It's fundamentally fuzzy. Second, chaos theory showed that even a near-perfect snapshot isn't nearly good enough. The tiniest error blows up. And finally, undecidability revealed that even with a perfect snapshot, some futures just cannot be calculated ahead of time. Period. You know, in the end, Laplace's demon was an absolutely brilliant idea, but it was a flawed one. The universe isn't some simple machine just following a script that was written at the dawn of time. Its story has inherent fuzziness, genuine surprise, and the freedom for a future that is truly new and unwritten. And that leaves us with this really fascinating question to think about. If we don't live in some simple clockwork universe where the future's already set in stone, then what kind of universe do we live in? And what does all that unpredictability really mean for us?